The derivative is a brand new function derived from the original function that spits out slopes of tangent lines. So I've got some original function here, f of x. We just did this in a previous video. We know this is his derivative. So here's the original function in blue. This brand new function, if you give it an x value, it tells you what was the slope of the tangent line to the original at that x value. So for example, let's take a look here. Look at, say, that x value on the original, on the blue curve, f of -1, maybe. Would be -1 squared 1 minus 2 times -1. So that's 1 plus 2, that'll be 3. That's that point right there. That's an ugly 3. That's a point on the original. The derivative looks at that point and goes, I don't care how high or low I am. I want to know how steep is the curve at that point? How quickly is that graph changing? So if I draw in my tangent line, look at that slope. That's a negative slope. F prime at -1 now I'm using this function, will be 2 times -1 minus 2. So what is that? -4. That blue line there has a slope of -4. That's this point right there. The derivative spits out slopes of tangent lines. So let's just look at this broad picture. Look at this whole chunk of the graph here. In that entire region, my graph is going downhill. We're always thinking from left to right, always from left to right. This graph is decreasing. All of these tangent lines here would have negative slopes. So the derivative during this whole region is negative. Look at all these derivative values, all these y values on the derivative. These are all negative values because the original function was decreasing. Look at all of these values. I don't care how high or low the function is. I'm looking at whether it's going uphill or downhill. This graph is moving up. All of my tangent lines, if I look right there and draw in a tangent line, that has a positive slope. All of these guys will have positive slopes. The graph is increasing. So my derivative during that region is positive. And notice, see, these tangent lines are getting more and more positive. It's getting steeper and steeper. So the derivative is getting bigger and bigger. And notice right here at that spot, if I draw in a tangent line, I'll get a horizontal line. Right there, the slope of the tangent line is 0. Look right there, the derivative is 0. We're going to do a lot of optimization problems later where we're looking for the maximum or minimum value of a function, and that's how we do it. That's the main use of the derivative, is finding that kind of spot right there where the slope of the tangent line is 0, because that occurs either at a maximum or a minimum. Okay, so you can read all this here. When the derivative is negative, this section here, I'll color code it. The derivative is negative here. That corresponds to these x values when the function was going downhill, decreasing. And in this region, the derivative is positive. We're above the y-axis. Remember, up here is positive. Down here is negative. All of these derivative values are positive because the graph is increasing. It's getting bigger and bigger. Positive derivative is an increasing function. Negative derivative is a decreasing function. And those two meet right there where the derivative is 0. That gives you a horizontal tangent line. And we'll see later that corresponds to a local or global max or min.